back, folks. Last time we did quite a lot of scripting, and I would like to continue with that today. So we still need to finish implementing our basic functionalities, so that's what we'll be focusing on today. I'm also going to show you a few other constructs and why and when we would want to use them. So first, let's head back over to our chest script and take a look. Before we carry on with more functionality, I actually want to do a little bit of cleaning here. This process is called refactoring, and a lot of people prefer to leave it until the very end after all the code has been written. I usually find if you fix up small things as you go, you don't end up with a huge pile of work at the end. One of the most basic ways you can refactor or tidy up your code is to look for repetition. We want to try and avoid repetition as much as possible. One, because programmers are famously extremely lazy and don't want to write the same thing multiple times, even if it's just copy pasting lines of code. And two, because repetition makes your code less resilient and less reliable. So let's have a look at an example of that. For example, here we're using the literal string NUseTries several times throughout our main function to refer to our local variable. Suppose we were working on this code as part of a team, and the team suddenly decided that this is a really bad name for a variable and that we need to change it. We would have to go through all our code here and manually retype this variable name to the new name. There's a probability when we're doing that we would make a mistake in spelling of the new name, or forget to change one of the variable names out, or commit any of the other dozens of common errors that humans commit when they're working with code. So a better solution would be this. The name NUseTries itself is just a string. Just now we're typing that string out literally. Instead, we can use the power of variables to make the code more robust. If we declare it as follows near the top, string SUseTries equals open quotes NUseTries close quotes semicolon. Then we can simply use our new variable SUseTries everywhere in place of our literal string. Now, if we want to change this variable name at some point or make some other adjustment to it, all we have to do is change it in one place. We don't need to look through the entirety of our code. I know just now it might not seem like a big deal with our function only being 30 or 40 lines long, but you might soon be writing functions that are hundreds or even thousands of lines. So if you imagine having to look through all of that code every time you want to make an adjustment. This is why we want to think about these good practices early, and then we can avoid making costly mistakes in the future. Let's have a look for other instances of duplication. So this looks like another likely candidate. We're retrieving the value of this variable, of the local variable NUseTries several times throughout our code. So we can do the exact same thing here that we did with the string. We extract it to a variable, and then we can just use that variable there. So let's put in int n local useTries equals get local int open brackets o chest comma s useTries close brackets and semicolon. So now we can fetch the number of tries at the start of our script, and then we can simply just reuse that value over and over again. Great. So now we can use n local useTries rather than doing these retrieval operations manually. Now, I also don't really like this line, set local int. And that's for several reasons. So for one thing, as already mentioned, we're using this line twice. Um, as we said, we should really try and avoid repetition where possible. Two instances of the same line isn't terrible, but I think once we start getting to three or four repetitions, we should definitely be thinking about doing something to avoid it. But since we're learning, we're going to be really pedantic about this today, and we're just going to say that this line is an absolute crime against good software engineering and it needs to go. The second reason I don't like it is because it only does one thing. It's very specific in what it's trying to do. It increments one integer variable of one object, and it is specific to that variable. Obviously, if we change out the inputs, we can put a different variable or a different object in there. Um, but as I mentioned in the previous video, incrementation is a really common function, right? You're going to want to do it a lot. So I think it's time that we made a sort of shortcut for this so that we're not having to manually set this amount, but rather we just pass in an object and a variable and let a separate function take care of that. So what I'm actually going to do here is close out the script, and instead I'm going to create a brand new script. One of the great things about programming is our ability to link pieces of logic together that exist in completely different scripts or classes or packages. We're actually able to use our inbuilt functions like um, get nearest object by tag or speak string or any of these other functions that we've used already, because someone else has written the logic for those scripts, and all that we need to do is provide them with some input and they work perfectly fine. But for a lot of scenarios, we don't have the exact functionality that we want. So sometimes we're going to have to write our own libraries, our own logic that we can reuse elsewhere. When we use inbuilt functions, they all look super clean on the page because all the complex logic is done behind the scenes. We want to try and emulate the same thing in our functions. So let's think about the functionality we want. Technically for this, all we really want to do is provide a function that adjusts the variable NUseTries on the object OChest and increases that variable by 1. Right, so we have three things there, three inputs. We've got our variable name that we want to adjust. We've got our object that's storing the variable. And if you think about it, we also have the amount of adjustment that we want to do to that variable. So increase it by 1. But in that definition, it's not really that useful. Again, it's only doing one thing for that variable. So how about we adjust this function so that it can adjust the value of any integer variable on any object by any amount. I can suddenly see that being a lot more useful, and it's not much more difficult to write. So what information do we need to know for this function? The same three inputs that we've already identified, except now they can be any value that we provide. So rather than calling our input object OChest, we can call it OSubject, and that will represent any object that we pass into the function. Rather than calling our string variable SUseTries or NUseTries, we can call it SVariableName, and that will represent any variable name that our OSubject is storing for us. And lastly, our shift amount doesn't have to be 1. We can pass in any integer, positive or negative, and then we adjust the integer variable by that amount. So now we're ready to write our function. This function won't return any data. It can do, but I think we can just adjust the variable and leave it. So it will simply do its work and then pass control back to whatever called it. So we can just make the return type here void. We'll also need to give it a descriptive name. I'm going to call mine adjust local int because that's what it's doing. Finally, we'll need to specify our three inputs that we're expecting from whatever is calling this function. And we've already discussed those. So let's put those in. Now, when we change the value of an integer, so we'll be calling this function anytime we want to change the value of any local integer. But by far the most common operation with integers is increasing it by 1. So let's save whoever is using this some time. We can make the magnitude of the shift be 1 by default. And that way, if it is just an incrementation operation, if they do just want to increase it by 1, they don't need to provide this value. All right, so now we need to write the actual logic, the body of the function. If you're following so far, you can try to write out this body of the function for yourself. We've already written a very similar thing. Remember what line it's going to be replacing in our chest script, and then try and emulate that. So the body of this function is just going to be a single line of code, and we're going to need to use all of our three input parameters that we've supplied. So if you like, you can pause the video just now and you can try that out for yourself. Okay, welcome back. So I hope you gave that a shot. If you didn't, don't worry, we're just going to go through that just now. So all that we're doing in this function is the exact same thing that we've already done in our chest script. So we're just going to use setLocalInt like last time, except this time the object that is going to be storing the variable is going to be oSubject, our first input parameter. The variable that is storing is going to be sVariableName, and the magnitude of the shift is going to be nShift. But we don't know the current value of that variable. So all we have to do, again, like last time, is retrieve it using getLocalInt, and then we're going to add the value of nShift to it. So remember, because we've provided a default for nShift as well, the default behavior of this function without a third parameter is going to be that it increments the variable, whatever is stored under sVariableName. And that's it. So that's our little neat looking function that we can use in any of our scripts to change the value of any local integer variable. So one other thing that we do before we close this out, let's just copy our function definition, just the definition, and paste it somewhere near the top of the page. We don't need a function body this time, so we can just close that out with a semicolon, and then we can just add a little comment on the line above this. So let's describe what this function is going to be doing. We can say this function adjusts the value of local integer variable sVariableName stored on object oSubject by a magnitude of nShift. Cool. Okay, so let's save this. I'm going to preface the name here with an underscore. This is kind of my convention. A few languages tend to use something similar as well. This just basically means that I'm only going to be using this script internally. So there's nothing the player does will directly call functions in the script. This is just going to be my set of helper functions that are going to be used by other scripts. So let's now head back to our chest. You'll notice if we try to use our new function that we can call it here, right? If we look it up in the function search, adjust localint, we get no results. That's because we've forgotten to include our new script into this one. So our script need to communicate with each other, namely because our chest script is going to be using something from our helper script. The chest script needs to know about the existence of the helper script. So the include function tells our script to look for other scripts with a specific name and then make their functions available to us here. So if we use the hashtag include keyword at the very top of the script, followed by the name of our helper script in double quotes, we should now see if we've done everything correctly. There it is. Great. So now we can get rid of those complex and ugly lines of code and replace that with a nice adjust local int. Since we are incrementing, all we need to do is pass in two parameters. That's going to be our object, which is going to be oChest, and the name of our variable, which is suseTries. Perfect. And that, as you will see, that already looks much neater than when we started. So what we've actually done with that simple example is we've written our very own library. This is a lot more significant than it may seem. We now have a generic function that can be used across any of our own scripts. With a simple include statement, we can get access to it from anywhere else in our code. You can also share your libraries with other developers, and the advantage of that is they don't need to understand any of the code you've written. As long as you've written your code correctly and it all works properly, and they know what inputs to provide into that function, they'll be able to use any of your logic without having to read or understand any of it. So it makes it really, really simple for them. So that's pretty good. But with all this talk of libraries, we've actually not finished the basic functionality of our script. So let's go back to that. Now, we still need to do a couple of things in this part. So first of all, we're going to need to adjust the faction reputation of the player and make the Goblin tribe hostile rather than neutral after the third attempt to open the chest. Um, and this might seem a bit redundant since, the goblins are going to attack our player anyway, so why do we need to change the reputation? That's just a little safeguard in case, our goblins attack and the player manages to escape somehow. Maybe they go into stealth or, maybe they teleport away. If they do come back later, then the goblins should remember that they should be attacking the player. Okay, and after we've done the reputation adjustment, the second thing that we're going to want to do is we want the chieftain to attack. And not only that, we want the rest of the tribe to attack as well. So for that, what we're going to need to do is individually assign the attack command to every member of the tribe. So that's going to be quite a lot of logic. Since we've already covered custom functions, let's make another one. And this time the function is going to be specific to the script, at least for now. So let's make it inside here. And then just so you can see how internal functions work as well. So we could, of course, keep all the logic inside the final part of the if statement here. So we could do the adjust reputation, we could do all the attack commands, but that's gonna start looking a little bit messy, a little bit untidy. Um, since this is a separate part, logically, if you think about it, this is a separate action that we'll be taking. So it makes sense for me to put that into a separate function that we'll be designing. And that's the general kind of use case of functions. You really want to, and again, there's different schools of thought on this, right? Some people like keeping everything within, one structure. For me personally, I want to keep my main function as tidy as I can, and that usually means that I'm making a lot of other different functions that the main function can then call to do its logic. So let's make our brand new function. There are various conventions again for this among programmers. Typically, I would say you want to have your main function at the bottom. So the reason for this is because the script compiles from top to bottom from the first line onwards, it's basically forced to read all your other code before it reaches the main. Now, the main is always going to be the first thing that it starts executing from, but because the compiler has read through the rest of your code, it will be aware that these other functions exist. If you have the main at the top and then try and call a function that you've written further down, the compiler will throw an error because it doesn't know that that function exists yet. So there are ways to get around this, but for simplicity, I think keep your main as the last function inside your script, and then that saves you all the trouble of having to find workarounds. So above our main function, let's insert a void, and I'm going to call this attack the player. This is going to need two input variables. That's going to be a reference to our player character and a reference to one of our faction members. Since we already have a reference to the chieftain in our main function, then we can use that. So we'll see in a sec why we need both of them. So let's add object OPC and object OFactionLeader to the list of inputs. So the first thing that we want to do in the body of this function is to adjust the player's reputation. If we search up reputation in the function finder, we'll see that we already have a function for this. It's called adjust reputation. The documentation here also gives us a helpful tip on how to adjust reputations for player characters specifically. So if you see this little comment here, what we want to do is pass in the player object first, then an object that is a member of the target function that we want to adjust the player's reputation with, and then the shift in reputation. So we have access to all this information already, so we can just add this statement. Adjust reputation, open brackets, OPC, comma, O faction leader, comma, -100, close brackets, semicolon. This will change the reputation of the PC with members of the chieftain's faction, which is the Goblin tribe, by -100. And that's going to turn them hostile regardless of their previous reputation. If you remember, the maximum reputation with a faction that you can have is 100, and the minimum is 0. So if we're doing -100, that will always put the player at 0 reputation. Now, our final piece of functionality is to get all the members of the tribe to attack our player. Practically, this means that we somehow have to cycle through each individual member of the tribe and give them the attack command. So for us to understand how we do that, we briefly need to cover another programming concept, and that's going to be iterators and loops. So when we run the game, the engine maintains a lot of data behind the scenes. One of the pieces of data is a list of all the members of each faction. So there exists somewhere in the internal logic of the engine a list of all the members of our Goblin tribe. We don't know what order this list is in. It might be alphabetical, or it might be sorted by some internal ID, or it might be randomized each time the game launches. Um, the point is, each member of the Goblin tribe appears in that list exactly once. So if we reference everything in that list, we know that we're going to be referring to each member of the tribe exactly once. So when we want all the members of the tribe to execute some action, like as we do here, we want them to attack the player. All we need to do is find that internal list and go through it one by one. We can then individually get each object and issue the command. The thing you might be thinking here is, I, as the programmer, know all the members of the Goblin tribe. I created those NPCs, right? So why don't we get all our members individually? Object O basher equals get nearest object by tag basher. Object O fluffy, get nearest object by tag fluffy. And then, just do the assign command like we do for the chieftain. You could do that. You absolutely could, and your code would work. But that makes it extremely inflexible, right? If you decide to then go, add more members to your tribe, for example, right? You would have to go back to the script and add the names of each new member and tell them to attack. Worse yet, if you remove a member from your tribe later on, and they're still referenced in the script, your script will probably crash or at least throw some sort of error because it can't find the individual member that you're referring to. So what we do instead when we want to achieve this effect is essentially we say, hey engine, I know you have this list of faction members. I don't know who's in it. I don't know how many people are in it or what order it's in, but I want you to go through this list, and for each entry there, we're going to do some action. So when we want to run the same command a lot of times, which is what we're going to do, we're going to run the attack command 4 times or 6 times or however many faction members you have. What we typically want to do is use a programming structure called a loop. Now, like a looping track in a Formula One race, it goes round and round the same thing, and either it does it a certain number of times. For example, that could be like 10 laps, right? So do this code exactly 10 times, or until some condition is met. So run this code until this condition is false, or run this code until this condition is true. Although it's not really the case, since many languages now have hybrid types of loops and more complex types of loops. Originally, the rule of thumb was this. So you would use something called a for loop if you knew exactly how many times to run the code. So that would be, run your code exactly 10 times. And you would use something called a while loop if you didn't know exactly how many times you wanted to run your code. So run this code until something happens. So what we want to do here is think about which one is better for our purposes. Now, we want to run a piece of code which is attack the player for each member of the tribe. Now, you as the programmer, you know exactly how many tribe members you have just now, right? But suppose we want to allow for the possibility of you adding or removing tribe members later on. You don't want to come in here and change the code every time you make changes to the tribe. It should work identically regardless of if you have 3 members or 15 members or however many, right? So the engine doesn't know how many tribe members it has, and it doesn't know the exact amount of loops or iterations that it has to run. So therefore, it makes more sense for us to use a while loop. So luckily for us, the engine provides an internal iterator for us for the exact purpose of looping through each faction member. So let's briefly go over how an iterator works, and then I'll put it all into code. And then maybe if this isn't making a lot of sense just now, seeing it on the page, you can maybe that will give you a better understanding of it. So we're already familiar with getter functions that give us an object back. So a getter function is something like, get last used by, which we used, which gives us back our player, or get nearest object by tag, which we could use to find NPCs. All a getter function does is allows us to create a reference to a specific object in the game world. So such as the player or chieftain or whatever else, right? So our iterator works in almost exactly the same way, except now we have multiple objects that we need to reference. So if we think about that hidden list of faction members that I mentioned earlier, when we call an iterator getter function, the iterator itself returns to us the first object, so the first faction member on that list. We can create a reference to it as normal. We can assign, an object ID, essentially a variable name. So let's write the code for it, and we can see how it works. Maybe it'll become a little bit more clear. So the first thing we need to do is create our iterator and get back the first object on that list. So what we're going to do is declare this object oFactionMember equals get first faction member, open brackets, oFactionLeader, comma, false, close brackets, semicolon. Don't be distracted by this second parameter false here. This is just an indicator that we can include NPC faction members rather than only PCs. It's irrelevant to our discussion for now. So what we're actually doing in this function is saying, hey, I have this object, oFactionLeader, and I know that this object is part of a faction, and I know that the engine has an internal list of all the members of that faction. So get me the first object on that list and assign it to the variable oFaction member. Now, remember, because we don't know the order of that list, this can be any of our camp denizens, but that doesn't matter to us since we're going to go through them all one by one and we're going to execute the same logic on all of them. Now, this is the part where we want to begin executing our loop. So let's open our loop. We can do this as follows. Just write the word while and then open and close the circle brackets, and then we can declare the body with curly braces. Now, same as our if statements that we've looked at before, the round brackets should contain some condition that evaluates to either true or false. As long as the condition is true, the body of the loop will execute. It's then going to check the condition again once it gets to the bottom of the loop. If the condition is still true, it's going to run again, and so on until the condition is false. So what this means is that the condition will eventually need to change to false, otherwise we get stuck in what's called an infinite loop. Basically, we just keep going round and round again and never exiting this loop. And that this change to false needs to happen somewhere inside the loop. Remember, the body of the loop is the only thing that we're going to be executing until this condition is false. So I'm going to leave it blank for now. You'll see how we do that in after we fill out the body, right? So first of all, let's think about the functions that we want to repeat here. So the only thing that we want everyone to do is a simple action attack, right? So we already know how to assign actions to NPCs, so let's add that first thing now. We can call assign command, open brackets, oFaction member, right? That's going to be the object that is going to be executing our command, comma, action attack, and if we look at action attack, it just takes a target. So who do we want the oFaction member to attack? That's going to be our OPC, right? So close the brackets and close the outer set of brackets again, and semicolon. Very simple, right? So we want whichever faction member is there to attack the player character. Now is going to come the magic of iterators, right? So the variable oFaction member is currently referencing one of the goblins from our list. We don't know which one it is, but let's suppose it's Basher in my case, right? So now Basher has been given the command to attack the PC. So he's already doing everything that we need of him, which means we can now reuse the variable oFaction member to refer to something else, which is precisely what we're going to do. So let's write our next line of code, and then I will explain it. oFaction member equals get next faction member, open brackets, oFaction leader, comma, false, close brackets, semicolon. So first of all, we're not using the keyword object here before oFaction member. This is because the engine already knows that oFaction member is a variable of type object. If you think back all the way to our first scripting video, then remember we only need to declare the type of the variable once. We're only declaring it at the top. Since we already said that this is an object, the only thing that we can put in oFaction member is other objects. So as long as we assign another object to it, it will be happy. Secondly, we're calling the companion function of get first faction member. So there are several of these kind of get first, get next functions for cycling through various types of lists. So you can get something like, all the players on a multiplayer server, all the items in a player's inventory, and so on. So now we can see them both in action together. When we call our get first faction member, we're instructing the engine to create an iterator for the internal faction list and give us back the first item on it, our first faction member. When we then call get next faction member, we're essentially reminding the engine that it already has an iterator created for that list and to give us back the next item on that list. So here we're assigning whatever the second member of that list is to the variable O_faction member. So let's suppose it's the chieftain. So what happens when we get to the end of that list, right? We don't know how long the list is. So the answer is, it's written here in the documentation actually. If we call get next faction member, but there are no more members on that list, we simply get an object underscore invalid. So this is a special object that is used precisely for what we need in the loop. With all that information in hand, we now understand how we can structure the loop conditional, and I hope this will become clear now. Let's go back to these round brackets and put in the following condition. Get is object valid, open brackets, O_faction member, close brackets. Simply put, the condition is that we want to check before running each loop, is the object currently referenced by the variable O_faction member a valid object, or is it object underscore invalid? If it is a valid object, then we can go ahead and execute the body of our loop because get object valid is true. If it is object invalid, then get is object valid is false. So we don't need to execute the body of our loop anymore, and we can move on to the next thing. So if this is still a bit confusing, if this is still a bit unclear, let me demonstrate how it would work in practice. When we call this function at first, we will do a reputation adjustment. We just do that once, right? This is outside of the loop. So we're just calling that, we're just doing that part of the logic once. And to demonstrate how the iterator works, I'm going to make a little list at the bottom here using the magic of video editing. So here we're going to call our get first function. The engine pulls up a list of faction members that are currently in the same faction as O_faction leader, who's our chieftain, and it creates an iterator. The iterator is currently pointing to the first item on that list, and that's Basher. So we can assign Basher to O_faction member and then begin our loop. Our loop conditional then does a check. Is Basher a valid object that exists in the world? Yes. So we go into the body of the loop and we issue the attack command. Now, since we're done with Basher, we then reassign the variable O_faction member by calling up getNext. The iterator already exists for this, so we get the next object on that list, and that's going to be the chieftain, and we assign that to O_faction member. Then, since we're done with the body of the loop, we go back and check the condition again. Is the chieftain a valid object? Yes. So we can execute the body of the loop again, get the chieftain to attack on this line, and then we're calling get next once more. So grab the next item on our list, and that's going to be Fluffy. So Fluffy gets assigned to O_faction member. Then the loop is finished. We go back to our condition. Fluffy is valid, and so we run again. Do all that logic. Hopefully you get how this works. And then we assign shooter to the variable, do our validity check. Shooter is also valid, so we go through it all. Now, with shooter assigned, we request the next item on the list again. Since there are no more items, we're expecting something, but there's nothing on the list. So what we get back is object invalid, and we assign that to O_faction member. This time, when we go back to our loop conditional and check if this object is valid, it's clearly not. So that means our loop is done and we can move on to whatever bit of code is next outside of the loop. Since we have nothing after the loop, the function finishes at this point and returns control to whatever function originally called it. All right, so if you've understood all that, then well done. This is quite a tricky concept if you've never seen it before. I think we've gone through quite a lot of complexity today, so the rest of it is going to be a little bit of cleanup and some aesthetic improvements to make our code look even nicer. First of all, the function that we just wrote, I'm using O_faction member and O_faction leader rather than like goblin and O_chief on purpose. because I think this function is also a candidate for reuse in the future. Maybe if we have that camp of angry dwarves that we talked about earlier, we could also get all of them to attack the player for some reason, right? So I think this is something that we could probably use again in a different script. Uh, with that in mind, I think it's a good candidate to become one of our helper functions. So let's cut this one out and we can paste it inside the helper function script. So remember, if you want this function to appear in the function's lookup, we also need to declare just the signature and place a comment above that. So let's do that now. We can add the comment, members of O faction leaders faction all turn hostile and attack OPC. Seems fairly nice. Okay, now there's actually a slightly better way of doing action attack. Action attack is a specific strike that will initiate combat, but it does have some limitations as opposed to a full-on combat scenario. So what we're actually do is just going to replace this with determine combat round. But if you look this up in the function menu, it's not available to us. That is because determine combat round actually lives in another library. Since we already know how to include libraries, let's do that now in our script. At the very top, let's write out hashtag include, uh, open double quotes, and then in all caps, NW underscore I0 underscore generic, and close quotes. So this is just one of the internal scripts that expanded some of the game logic, including giving us determine combat round. So now if we look up that function in the function search, we should find it fairly easily. So let's replace action attack with that. Nice. So let's go back to our on chest use script and then we can make some additional improvements there. So first of all, let's add our attack. Since we already have the helper functions included, we should just be able to search up attack the player in our function search and it will come up. It makes sense to do this right after the chieftain issues his final shout. However, we might run into a little issue here. For the chieftain object specifically, we are issuing two assigned commands right after each other. The shouting action and then the engage in combat action from the attack function. So they both assign a command to the chieftain object. They will be a fraction of a second after each other, so close that the combat initiation might actually override the shouting command. What this means is, in practice, is that the chieftain might not do his final shout. That actually depends on a number of internal kind of factors, but there's possibility that our shout command gets overridden by the attack command. Now, what we want is the chieftain to make sure he does do his final shout. The kind of quick and dirty solution that I'm going to use here is to put in a small delay before we do the attack. Now, the delay will be so small as not to be noticeable by the player at all. But in terms of machine processing, it will be sufficient time to process both the shout and then the attack commands correctly. So all we do for a delay is we wrap the entire call in what's called a delay command function. You'll see that it takes two parameters. You can do this with almost any action. Right? You can delay almost anything. So for our time, we'll add 0.2. So that's just going to be 1/5 of a second. The player is not going to be able to notice this at all, but the engine it'll make a big difference to how the engine processes these commands. So you may notice that the input parameter here is of type float. That's something that we've not encountered before. Float is short for floating point number. That's basically any number that isn't a whole number. Since we want to use fractions of a second here, we're going to want to use a float rather than an int. Finally, I want to tidy this up as well. The chained if else's look a little bit messy for my liking. Too many curly braces and it's kind of difficult to follow. So this part I'm going to leave as optional. I think a lot of people do prefer the if else kind of style stylistically. Regardless if you want to follow this next part or not, I think the functionality, well, I don't think, I know the functionality will remain exactly the same. So I would encourage you to watch through to the end anyway, because I'm just going to discuss another couple of brief concepts here. So for those that want to follow along, let's take a look at the statements. Essentially, each condition is checking the value of the same variable. That's our local variable NU's tries. Depending on the value of that variable, so 0, 1, or 2, we want to have a different outcome. Is there a nicer looking way of switching between these conditions? Turns out there is. Rather than doing all of these complex equality checks, we can simply use the statement switch. Switch takes a single parameter, that's going to be the variable that we're switching on. And in this case, the variable that we are testing is the local variable in use tries. So let's do a switch on, remember we get it up here, so we can switch on n local use tries. Like always, we need to open a set of curly braces to contain the body of the switch. Now we know that n local use tries can be 0, 1, or 2. These are called cases. This is where the simplification comes in. For each scenario, we can simply write out case followed by the value and add the logic from our relevant if statement. So if it's 0, we can just copy these lines here. If it's 1, we can copy these lines here, and if it's 2, we can copy that as well. So finally, we need to tell each case when to stop reading. Because cases are unique in not using curly braces, they consider all the cases to be one continuous bit of code. The code will begin executing from the correct case. So for example, if n local use tries was 1, it would start executing from this line case 1, but it will continue running through all of the cases below unless we don't explicitly tell it to stop. And that's going to go all the way to the end of the switch. So simply at the end of each case, we're going to use another keyword called break. Break is a very useful tool. It basically tells our compiler that we want to break out of the nearest enclosing set of curly braces and go on to the next line. So the nearest set of curly braces is the body of our switch statement here. So when we encounter the keyword break within this body, it will skip everything until the first closing curly brace here and then carry on from there. So break is also very commonly used in loops as a way to close them out as well. It's one of the protections that we have against infinite loops. So now that we've got all that, we can delete our various ifs and take a look at how neat and tidy our code looks. Provided we've done everything right, we can save the scripts and test our creation. So our first and second interaction with the chest should yield the expected lines from the nearby chieftain. Our third and subsequent interactions should turn our entire tribe hostile towards us and initiate the combat scenario. Alright, so that was quite a lot of work for what seems to be a simple interaction. But as always, I think the amount that we've learned over these past two videos is quite impressive. So if you've never looked at that before, if you've never seen, loops or iterators or any of that stuff, then that's a lot of learning. So we've covered, chaining conditionals, we've covered custom functions, we've covered the include statement, while loops, iterators, delays, case statements, and a few other things that I've probably forgotten about by now. As always, if you feel that something is confusing or not explained correctly, please do leave me a comment or send me a message. I'm always trying to get better at presenting information in an accessible way, so your feedback is very, very valuable to me. And if you feel I'm doing a decent job and you're kind of fully on board with it, then please let me know as well. From the next video, I'd like to take a break from the scripting aspects for a little bit and refocus on our storyline. We'll be making the camp a little bit more dynamic by having the NPCs move around and act like real people. Lastly, I'd also like to invite you to send me some feedback on some of the things you'd like to see in future tutorials. Maybe you're making your own campaign based off this, and some part of the tool set is eluding you. I'm happy to try and go through that and explain how that works. I'm trying to keep a decent balance between kind of coding, design, and tools. But if there's a specific thing that you want me to discuss, please let me know so that I can include it in a future video. So until then, thank you very much for watching, and I hope to see you again soon.